Welcome to our channel Learning Math. In this video, we're going to learn the second part for rules of powers for grade 7 in math, powers and exponents, how to write a base carrying one exponent, how to solve when we have different bases when we multiply, add or subtract. Here we're going to learn about them. Now let's start together. If we have a base carrying more than one exponent, we should multiply them. Why? Here is an example. If we have, for example, 3 to the power 5 all cube, what does it mean all cube? It means we are multiplying 3 to the power 5 by itself for 3 times. Well, what does it mean? Here we are having same base between them times, so we can add the powers. So it's a 3 power 5 plus 5 plus 5. Well, how many times did we add this 5? Isn't it 3 times? Well, can't we write it directly 3 times 5? So when we have a base carrying more than one exponent, we can directly multiply these exponents 5 times 3. So it's 3 to the power 50. So any base carrying several powers, we just multiply them. In general, we say a to the power m all to the power n equals a to the power m times n. For example, 5 cube all square is 5 power 3 times 2 equals 5 power 6. In general, x square power 4 equals x power 2 times 4 equals x power 8. Here are some applications. We can multiply the powers directly. As you see, another example, a base carrying 3 powers. How to solve it? We can directly multiply these powers. It's minus 1 to the power 2 times 3 times 3. We multiply all the exponents. So it's minus 1 to the power 80. Another example, as you see, here we have a base carrying more than one exponent. It's 5 to the power 2 all cube times 25 square. On the other hand, we have another base different from 5. How to solve it? First of all, we should keep in mind that 25 is 5 square. We can transform it into the same exponent. Then we apply the rule of powers. The first one, 5, carries 2 exponents. We can multiply them. So it's 5 power 2 times 3 is 5 power 6 times 25. We can replace it by 5 square. We have 25 square. We copy the other power, which is square. So it's 5 power 2 times 2 equals 5 power 4. Now we are having the same base between them times, so we add the power. So it's 5 power 6 plus 4 equals 5 power 10. Well, what happens if we have different bases and we cannot transform them into the same base? In general, the priority in operations is for power and parentheses times and divided by, finally plus and minus. If we want to calculate the final answer and not write as a base carrying one exponent, how to calculate? We start calculating from the power and parentheses, then times and divided by, finally plus and minus. How to solve? Here are some examples. For example, 5 times 2 power 3 times 3 power 2. We want to calculate them. First, we underline our focus. We should start by the powers. We have 2 cube is 8 and 3 square is 9. We solve them and we copy the rest here. We have 5 times, we copy it. Now we can start solving. 5 times 8 is 40 times 9. We copy it. 40 times 9 is 360. Another example, as you see, we have minus, parentheses, plus, power. How to start solving? Sure, we start by the terms between parentheses. 2 plus 4 is 6. Sure, we copy the power, so it's 6 square. Also 50 minus, we copy it. Now here we have minus and power. We should start by the power. You know that 6 square is 36, so 50 minus 36 gives us 40. This is very important. Well, now we're going to learn some properties that are very important for powers. If we have 3 plus 2 all square and 3 square plus 2 square, are they the same or not? Let's solve them together. 3 plus 2 all square, we should start between parentheses. We have 3 plus 2 is 5, so it's 5 square equals 25. What about 3 square plus 2 square? We have power and plus. Sure, we start by the power. So here 3 square is 9 plus 2 square, which is 4. 9 plus 4, 13. Are they equal or different? They are different. So here we can conclude a rule. Power is not distributive over plus. If we have 3 plus 2 all square, it's completely different from 3 square plus 2 square. Another example, what about minus? Here 5 minus 4 all square. The priority is for parentheses, so 5 minus 4 is 1. We can write it 1 all square, so it's 1. What about 5 square minus 4 square? We have power and minus. Where to start? We should start by the power. So 5 square 25 minus 4 square, which is 16. 25 minus 16 equals 9. Well, are they equal or different? They are completely different. So we can never distribute power over minus. So here we can conclude that power is neither distributive over plus nor over minus. Well, what about times and divided by? Let's start by the first example. 3 times 2 all square. Sure, the priority is for parentheses. 3 times 2, 6. 6 square gives us 36. Now what about 3 square times 2 square? We should solve power then times. 3 square is 9. Times 2 square gives us 4. 9 times 4, 36. So here they are the same. We can say that they are equal. So we have a rule. Power is distributive over times. In general, we can say if we have a times b all to the power m, it's equal a to the power m times b to the power m. So power is distributive over times. Let's see what about divided. Here is an example. 10 over 2 all square. We should solve first what's between parentheses. But 10 over 2 is 5. So isn't it 5 square? Equal 25. What about 10 square over 2 square? We should solve power, then divide it. 10 square, 100 over 2 square, 4. 100 over 4, isn't it 25? Aren't we having the same answer? So they are equal. Here we conclude that power is distributive over divided. So the most important rules that we should keep in mind for power are: power is neither distributive over plus nor over minus, but power is only distributive over times and divided by. So a times b all to the power m equals a power m times b power m. We can distribute this power over times. Also, when we have divided by a over b all power m, it's a power m over b power m. Now here is an example. 10 square over 2 square. We can write 10 as 2 times 5. All square, sure, we keep on the power. Well, here we have times, we can distribute the power. So it's 2 square times 5 square over 2 square, we copy it. Now as you see, we can simplify 2 square by 2 square, so it gives us 5 square. Here was an application. Thank you for watching. If you enjoyed this video, please like, share and subscribe.